Hi guys. So in this video, we're going to solve one more problem on combinational logic circuits. So this is going to be much longer than the ones we've treated before, and it's a longer word problem with even more conditions. So by doing this, by walking through the solution for this question, we're going to be able to get more confident when tackling combinational logic circuits problems. A classroom contains a control unit, a motion sensor, a glass door sensor, and a glass break sensor. Design a digital alarm system that activates the alarm whenever the control unit is on and any one of the following sensors is triggered: the motion sensor, door sensor, or the glass sensor. Additionally, the alarm should also activate when the glass sensor detects a breakage event. So, usually before we even get to drawing our truth tables, it usually helps to give ourselves a rough idea or a theoretical idea of what we're doing. So our output is an alarm. So we can call our alarm on output, let's say a speaker of some sort. Okay. And we have a handful of inputs. We have 4 inputs in this case: a control unit, a motion sensor, door sensor, and the glass break sensor. So let's use the letters for these appropriately. So C for the control units, M for motion, G for the door sensor, and G for the glass break sensor. Design the digital alarm system that activates the alarm whenever the control unit is on. So since there are 4 terms here, we're going to have, recall the form. Recall what we've established in the previous videos. Since our inputs are 4, then the number of rows we're going to have is 2 to the n. So that's going to be 2 to the 4, which is 16. Okay? So meaning we'll have 8 states where this is off. 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So our control unit for this condition here, the control unit has to be on, and at least one of the sensors has to be triggered, either the motion, the door, or the glass sensor. So if I go this way, so let's do 4, alternating with 4, then 1, then 1. Okay. Alternate 2, 1, 2, 1, 2, 1, and then we go 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So let's look at this. For this set of conditions, our control unit has to be on, meaning that for these first 8 states where the control unit is off, which is this set over here, we are not going to care. This is not going to be part of our output. Okay, so the control unit has to be on. That's the first thing we're going to establish. And one of the following sensors has to be triggered. So look at the rest of the truth table. Given that the control unit is on, which conditions do we have here that at least one sensor is on? All right. So for this first one, we can see that the control unit is on. That's a 1. And every other thing is off. So which means that although the control unit is on, no other sensor is triggered. Meaning for our alarm, okay, so let's bring this closer. For our alarm, we can even say that the entire, okay, let's leave that for now. W, okay, just so I can have this correctly. So for this state, even though the control unit is on and no other sensor is on, meaning we're going to have a low alarm output. Okay, but for every other scenario in this case, here the glass sensor is on. By on, I mean detects a breakage. Okay, so 1 for the glass sensor means does it detect a breakage? 1 for the door sensor means is the door being opened? And 1 for the motion sensor is whether there's motion in the room. Okay, here the glass sensor is on, so we can write this high. Here with the door sensor is on, can write it high. Here we have both of them on. So given that our first condition says that and any one of the following sensors is triggered, meaning that we can have more than one, since we are working with the OR operation. All right. So we can fill in the rest, since the condition is met for at least one other sensor being on. Okay? Okay, so our last condition here says that, additionally, the alarm should also activate when the glass sensor detects a breakage event. And given that our first condition states that the control unit has to be on, so we look for the situation where we have our control unit on. So that's these last 8 conditions right here. And our glass sensor detects a breakage event. So that's 1, 2, 3, and 4. And these are already covered in the first condition for the OR operation. For the first OR operation, given the control unit is on and any one of the sensors are triggered. Okay? So meaning we can fill in 0 for the rest of our unorthodox truth table. Alright, so that's all we have to do. So this is what our truth table for this. Okay, let's see if we can write this more elegantly. See here. Motion sensor, door sensor, glass break sensor, and our output for the alarm. Okay? Control units, motion sensor, door, glass break sensor, and output Y for the alarm. Okay? Four, 1, 2, 3, 4, 2, one and one. Okay? So alternating ones. Okay, so recall we said we have a high. Okay, this is going to be 0 since no other sensor is high. And then 0, 0, 0, 0, 0, 0, 0, 0. So it's important to know that the way we analyze the question, you said that the alarm being active when the glass sensor detects a breakage event is going to trigger our alarm Y. Okay, so this is our alarm Y being triggered by the breakage event. There's another way to look at this question, which may affect how you solve it. Okay, meaning that if you assume that the glass sensor can detect a breakage event without the control unit being on, that means that anywhere you have G as high, you're going to make this output 1. Okay, so this change to 1, this is change to 1, this is change to 1, and this is change to 1. But that's not how we're going to attempt this question. So it's the way this question is worded is not really explicit on whether this glass sensor can work with or without the control units. But the way we're going to solve it here, we're going to assume nothing is going to work unless the control unit is active, which is why we're going to have it the way we did. Okay, so trying to look at the scenario we have here, to now we need to write out a Boolean expression for this. So we're going to look at the region where this is high, where our output is high. So if we were to be really vain as to write everything out, this would be C, not M, not DG, or C, not M, D, not G, or C, not M, DG, or C, okay, M, not D, not G, or C, I've lost track of where I am. C, not M, not DG, C, not M, D, not G, C, not M, DG, C, M, not D, G. So C, M, not D, G. Or C, M, D, not G. Or C, M, D, G. So that should be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we may leave it at this. Okay? This is correct, but it's not the best way to write out the expression. We can get an idea of what's happening if we analyze the question closely. Okay? So they say that the control unit has to be on and any one of the following sensors is triggered. So meaning that control unit being on is constant. If we were to factorize out anything from this expression we have here, you see that C is always going to be constant. So instead, for a simpler problem, writing out every region where your output is high would be the way to go. But because we can simplify our problem, we'll say that this can be expressed as C, as our control unit, and M or D or G. And the reason for this is very simple. We looked at, if we were to factorize this out, we would get the exact same thing. But from just looking at our question, how the question is framed, the control unit has to be on, which is C. You can see that the output is not high anytime the control unit is low. And any one of these has to be on. So simply performing, if we were to ignore this rule and perform just the OR operation on these three, you see that the OR operation for this, 0 or 0 or 1 is high, 0 or 1 or 0 is high, 0 or 1 or 1 is high, like so and so till you get to the end. So instead of writing this out and having to deal with a 6-term sum of products, okay, we can just look at our question nicely and get this expression. We can now do for the second, write the binary expression for the second part, which is what does that mean? Okay. So the alarm should also activate when the glass sensor detects a breakage event, which means or the control unit and our glass sensor, which is what we went by when defining our problem. Okay. If you were to solve this saying that the control unit, the glass sensor can detect without being on. So this will be this, and this should just simply be OG. Okay, it should just be OG since G has to be a high for that. So drawing the circuits for this, you see, is actually pretty simple. Okay, so let's draw the lines for the expression. Let's do it for M. For M, do for G. Oh, how do I? Okay. Let's make them close together. So here we have outputs for M, for D, and for G. So we know that these are being odd together. So we need a 3-input OR gate to handle our first term. Okay. So out of this comes M or D or G, which is this part of expression. We'll need to AND it with C. So drawing our C, perform the AND operation. Okay. Okay. So you can see we've handled the first term. So let's label this out. So M, D, G, C for the control. And we need to OR it with CG. Okay. So taking this down. Okay, that's true. C, G. So remember that the gate we're going to use here is the AND gate, because while in this bracket we have M or D or G, here we have simply straight up CG. So it's going to be an AND gate. Okay. Remember, it's always advisable to first of all highlight where this comes out, and then follow through with your labeling, so you're very sure of what goes where. So out of this comes M or D or G. Okay. And this becomes C or M or D or G. Cool. Out of this operation comes CG. All right. And then the final thing we're going to do is to OR it together, since the Boolean operation tying two of them together is OR. All right. So bring them close enough so we can get a better looking output and perform our OR operation. And then what we have here is going to be C and M or D or G or CG. So it's a very simple thing going about creating combinational logic circuits. Even though it may looking at the solution firsthand, like just being given this from the beginning will definitely seem like a complex thing to do. But now that we've walked through defining our problem, understanding the scope, and writing out our truth table, from there getting our expression. So from the truth table, we're able to get our expression. Okay. Then drawing our combinational logic circuits. You can see that solving circuits, this type of questions, isn't as difficult as a problem. So now it's important to know that these things are sort of up to interpretation. All right. Since I saw that the condition where the glass sensor is on and the control unit is on, so that's this, is also included in this first set of expressions. What do I mean? Remember that the second part of the question says that the alarm should activate when the glass sensor detects a breakage event. So that means when I have a breakage event and my control unit is on. So that's the first way we could solve this. And the control units, SAC for control units, is on. Okay, then this will be the resulting expression. But if you assume that the glass sensor can detect a breakage event, even though the control unit is off, then this should just be and the glass sensor, meaning that all these other conditions where the glass sensor is high would form part of the inputs. So here, instead of having C and G, you just simply have G. Okay, so it would be or G. So these kind of things are sort of depend on how you set up your question. Both are valid, given you're able to explain why you came up with your decisions. So we should be able to solve more problems, but I expect that in the next video we'll head over to decoders, sequential logic circuits, so that we can fully understand the scope of digital electronics. So I'll see you in the next video.